Hello, good evening and good afternoon students, and today we are start discussions about the electric energy and power in the same topic, that is the electric current through the conductors. Then before the discussions of these contents, we are just revise in the previous lectures what we are discussions. The Ohm's law we are discussing the previous lectures, and the Ohm's law is the potential difference and resistance and electric current. They are shows the interrelations between these three different terms. They are related to the electric current. Then the Ohm's law, the electric current passing through any conductors is directly proportional to the potential differences applied across the two ends of that conductors. And after this we are some discussion the limitations of the Ohm's law and physical origins of Ohm's law. And in these lectures we are discussing the electric energy and powers. Let's take the heading, the electric energy and powers. And for the discussions of the energy and power in the form of electric energy, that is, we are drawn one of the circuit diagram here. We use one of the cells that will be joining as a positive and negative. We use one of the circuit, and in the circuit we use one of the cells, that is a battery. And in this circuit we are also use one of the resistors here. The resistors consider this is the resistors, and the resistors AB will be used in the circuits. Consider resistor AB in given circuit, in a given circuit. Then in the resistors the potentials is higher at a point A and potential lower at a point B. Then the potential is higher at point A and lower at point B. Lower at point, that is B, and the potential is higher at the point A and lower at point A, B. Then the V be the potential difference between the resistors, or potential applied potential across the resistor AB. Then V be the capital V be the potential difference across a resistor, across a resistor AB. Then this is the all about some summary of we taken some one of the circuit diagrams. Then let capital Q be one of the charges. Let capital Q be the charge flow in the given circuit, with the time t, with some time, that is delta t, with time, that is delta t. Then we know that the current of the given circuit is rate of flow of charges. Then the current I is equal to Q divided by delta t. This is the important and useful equations. We take one of the number of these equations, that is equation number 1. This is all about summary. Then when we know that potential difference and flowing of the charges. In the previous lectures we started to discussions of the Ohm's law. I will tell you what is the potential difference. Potential difference is a work done with unit charges. Then the work will be done in here, because the carrying of the charges, the flow of charges q will be flow in the given circuit, then potential difference is also in the circuit, then the work done. Then first we are write what is the potential difference, work done in the circuit per unit charges, then the work done is equal to, we are multiplied potential difference with the charges q. This is the another important equation, the equation number 2. This is all about summary. Then energy will be changes. Shell provided through charges, shell provided one of the energy through the charges q. The work done will be happen, force will be happen, displacement will be happen, potential difference will be happen. Then the cell will be provided some energy in the charges, flowing charges q through the resistors. Then cell will be provide some energy through the resistors. In these lectures we are discussed the electrical energy and power. For this we are start to discussions about the energy in the given circuit. Cell provides that is cell provide energy through flowing charges, flowing a charge q through a resistor AB. Resistor AB. Then charges will be flowing from here to here. Then positive charges will be flowing. Then at a point A, potential difference across a resistance AB. Then potential energy or potential higher at a point A. Then the charges will be flowing from A to B, and charges passes through higher potential level to the lower potential level. Then potential energy is decreases when the charges will be flowing. The potential energy is also decreases. Then energy becomes decreases. Energy is decreased. Energy decrease when charges flow A to B. Charges flow A to B, then potential difference is also decrease. Then higher potential to the lower potential will be the decrease, and energy is also decrease. And we write the change in energy, one of the formula, the change in energy we write the denoted as U. Change in energy is equal to initial energy and final energy. Change in energy is through A to B, then charges will be flow in the A to B, then charges Q will flow A to B, and potential difference, change in potential is also potential difference, that potential difference is a V. Then the same potential, what is the Q? Let's come to the equation number 1. I can write the Q for this equation, that is I into delta T. This is also equation for the charges Q in the form of current and time. Then I will be write the same equation in the side of Q, then I into delta T into V. This is the given another equation, that is the change in energy. I use the equations of the energy. By the principle of the conservations of energy, energy will be converted through the resistors, and we get the equations of the change in energy. Then du by dt with respect to time, du by dt, and here we write one of the text limit, the limit as delta T tends to 0. Delta T tends to 0. Energy will be conserved, energy converted by the principle of conservation of energy. Then we know that same using the delta T as a denominators, and we can cancel here, then I into V. या ठिकाणी काय केलं आहे du by dt, and it is we taken the smallest, then this is as a dt. Du by dt, du as equal to, and dt divided dt of the right hand and left hand sides, and we get of these equations. And this is the change in internal energy or change in energy with respect to time. It gives the power. Then du by dt is a power. Du by dt gives the power. Then power is equal to I into V. Then P, that is a power P. P is equal to du by dt is also is equal to I into V. This is the equation for the energy, and this is the equation for the power, but is not compatible equations. We use some another form. Then power is transferred through the resistors. Some examples we are taken, one of the motors and rechargeable battery are the examples of the power will be conserved or power will be converted, or power will be transferred through the resistors. And it is the form, it is the main reason for this, because the presence of electric field, then electrons are transferred or moved across the resistors. Presence of electric field, electrons moves across the resistors. Then when there are motions, randomly motions of the electrons, they collides of the ions of the surface of the conductors, and it will be increase the kinetic energy, the increase of the kinetic energy of electrons. And this increasing kinetic energy, it happens, the heat will be increased. The heat will be increased in the given circuit or in the given conductors. Then the dissipated energy is dissipated. Then dissipated energy, I can write here, dissipated energy P is equal to V square by R. V square by R, that is equal, it is also is equal to I square into R. This is the equation for the energy of dissipated energy in the given circuit across when the charges and electrons move across the resistors. This is all about one of the derivations we are solved for the electric energy and power. The electric energy, this is the equations for the electric energy, and this is the equations for the electric power. This is the equations of the electric powers. Then I will be take one of the examples, the power of dissipated across the resistors, which can be responsible for the heating of the conductors. Then I will be take one of the examples, one of the problem I will solve here. We take one of the water heaters. Before we are just revise what we will study in these lectures. Consider one of the resistors, that is AB, having the potential difference in between the resistors AB is a V, and the potential is higher at a point A and lower at a point B. We are use one of the cells across the resistors AB, and these resistors will form, the charges will be travels across the resistors, through the resistors. Then consider A, B is given resistors and potentials higher at a point A, lower at a point B. V is the potential difference across the resistors A, B. Let Q be the charge with the time flow of the charges with the time delta T. Then I use the formula for I, rate of flow of charges, and I will be use one of the formula for a charge. Then V, it is the potential difference, and work is done when the flow of charges with some potential difference, that is work done is equal to V into Q. This is the one of equation number 2. Then cell provided the energy flowing the charges Q through the resistor AB, then energy is decreased. Why energy is decreased? The potential of V, potential at a point A is more the potential at a point B, then charges will flow of this directions. Then Q positive charges flow of this directions. Then the firstly potential of a charges is more, and at the end of the resistor the potential of the charges will be less, decrease of potential, and this is the reason the decreasing of the energy. And change in energy, I will be use of this formula, and change in energy with respect to time, this is the power. Change in internal energy or change in energy with respect to time, this is the power, and I will be used equations of the powers. When the charges will be flowing, they are negative charges will be flowing, the collides of the ions and they form some kinetic energy will be increased. Kinetic energy increased, energy dissipated, and heat will be increased. Then I will be solve one of the problems. And electric heaters, one of the electric heaters having the current passing through the electric required current is I is equal to that is I, electric current is equal to 6 ampere, and the potential difference V is equal to 300 volt. Calculate the energy, calculate a power, that is question mark. We find a P. Then the resistance, calculate the power of the heaters and energy consumed by 5 hours, and energy be consumed, energy consumed by 5 hours. Conservation of law of conservations of energy, energy will be consumed, that is law of conservation of energy. We use these equations. Then that is the law of conservations of energy. I will use these equations and we can be solve of the given equations. First time we are use the law of conservations of energy, that is I into V, du by dt, dt is equal to I into V, that is 6 into 1800, it is a joule, it is the power, and we can be use the consumed energy, and this into this into the time, that is the time is 5 hours, and we solve these equations, these problems. This is one of the calculating part.